Page 5 of differentiation rules. We're going to work on the product rule. So this product rule is in the formula booklet, so you don't need to memorize it or anything, but it's pretty easy to memorize. It has a nice symmetry, a nice pattern. The way it appears in the formula booklet is like that. Okay, I think it's a little easier to understand like that. So unfortunately, the one that's harder to understand is in the formula booklet. Remember that the dash here, the dash symbol, means the derivative. So here you're taking the derivative of u, and here you're taking the derivative of v. You can see since they're added together, it doesn't really matter which order you do it in. Could be u dash v first or u v dash first. Doesn't matter the order you add them, because, you know, 1 plus 2 is 2 plus 1. Number 1, use the product rule to differentiate the following. Okay, so what we're going to do first is we're going to assign which part is u and which part is v. Usually we just, put the first one as u and the second one as v. If u is x and v is x minus 1, then u dash is 1 and v dash is also 1, right? So then what we're going to do is we're going to multiply these together. So we're going to do u dash v first. So we'll do 1 times x minus 1. And remember, the order doesn't really matter. And then we'll do x times 1. So that's equal to x minus 1 plus x, which is equal to 2x minus 1. Okay, and just to confirm, if we multiply this out, x squared minus x, if we took the derivative of the distributed form, we would get 2x minus 1. Same thing, right? Okay, now let's use the product rule to differentiate this u and this v. Okay, so u is equal to x squared and v is equal to the square root of x plus 1. I'm just going to rewrite square root of x plus 1 as x plus 1 to the 1/2 because it's a little bit easier to take the derivative of. The derivative of x squared is u dash equals 2x, and the derivative of x plus 1 to the 1/2 power is 1/2 times x plus 1 to the negative 1/2 power. And then we just multiply these two together, and then we multiply these two together. So what do we get? We're going to have 2x times square root of x plus 1 plus x squared times 1/2 x plus 1 to the negative 1/2. Can we simplify that? Not too much. That one, pretty much leave it as is. The only reason why you would simplify this is probably in the IB exam, maybe they're going to ask you to take another derivative of it. Maybe like that. Okay, not necessarily simpler, but it's a different way of writing it. Number 2, find dy dx using the product rule. So if this is u and this is v, let's find the derivative of that. So the derivative of u is 2x. The derivative of v is 2. So we're going to multiply this times this, and we're going to multiply this times this. So we're going to get 2x times 2x minus 1 plus x squared times 2. If we want to simplify that, we could distribute the 2x. So it'd be 4x squared minus 2x plus 2x squared. So that's equal to 6x squared minus 2x. So we could confirm that by distributing. The derivative of that is 6x squared. The derivative of that is negative 2x. Yeah, worked out. 2c. Let's find the derivative of this. So if this is u and this is v, let's rewrite v as 3 minus x to the 1/2 power. A little bit easier to take the derivative of. Derivative of u is 2x. The derivative of v is 1/2 3 minus x to the negative 1/2 times negative 1, because of the chain rule. Just to simplify this one, I'm going to write negative 1/2 3 minus x to the negative 1/2. Okay, and we're just going to do product rule, so we're going to multiply this times this, and we're going to multiply this times this. First thing you're going to do on a test problem, definitely write down the product rule copied from your formula booklet, right? 2x times 3 minus x to the 1/2 plus x squared times negative 1/2 3 minus x to the negative 1/2. And I don't think we can simplify that much this expression, especially the first term. Second term, we could write negative x squared over 2, 3 minus x to the negative 1/2. Oh, not, it wouldn't be negative 1/2 if I put it on the bottom. It would be positive 1/2, right? Okay. E. If this is u and this is v, then u dash is equal to 10x. V is equal to 3x squared minus 1 squared. V dash would be equal to 2 times 3x squared minus 1. And I need to do chain rule here. Would be 6x. I'm going to write the product rule. Then I'm going to substitute in. This can be simplified a lot, right? Not the first term. But the second term can. This 5 can be multiplied times a 2 and times a 6. So that would be 60. The x squared and the x can be multiplied together. X cubed. If you wanted to, you could distribute this too, but I don't think we need to. All right, number 3. Find the gradient of the tangent to this function at x equals negative 1. Now remember, gradient of the tangent is, if you have a curve, tangent line, slope, because gradient is a slope. So the slope of the tangent line to a curve at some specific point is the derivative. So all they're asking for is find the derivative at this point, which means we just find the derivative, like we have been doing, and then we substitute in negative 1. Turns out you can do that with the calculator. We'll confirm it with the calculator. So first, let's take the derivative of this function. It's a product, so we're going to take the derivative of this u and this v. So u is equal to x to the 4th. V is equal to 1 minus 2x quantity squared. U dash is equal to 4x cubed. V dash is equal to 2 times 1 minus 2x, chain rule, negative 2. So this can be simplified to negative 4 times 1 minus 2x. Probably can be simplified even more, but that's fine. Now we're going to multiply these two together and these two together. So we're going to multiply, let's see, 4x cubed times 1 minus 2x squared, x to the fourth times negative 4 times 1 minus 2x. Can rearrange that a little bit. 4x cubed, 1 minus 2x squared, minus 4x to the fourth, 1 minus 2x. Okay, so there's my derivative. And I want to find the value of this derivative at negative 1. So what we're just going to substitute in, negative 1 here, negative 1 here, negative 1 here, and negative 1 here. And let's see what we get. 4 times negative 1 cubed would just be negative 1. 1 minus 2 times negative 1 is 1 plus 2 squared. Minus 4 times negative 1 to the fourth is 4 times 1. 1 minus 2 times negative 1 is 1 plus 2. So we got negative 4 times 3 squared. So that would be negative 36. Negative 4 times 9, right? Okay. And negative 4 times 3 is negative 12. So that's equal to negative 48. Let's check on the calculator to see if that's really true. The calculator can do derivatives at certain points. Okay, so I'm just going to type the function, not the derivative, but the function itself into the calculator. And then I'm going to use the second calc derivative function. Let me just type it in offline. Okay, I typed in x to the fourth, parentheses 1 minus 2x quantity squared, and then I'm going to graph it. And then I'm going to do second calc dy dx negative 1, and that's going to give me the derivative at that point. The calculator cannot take the derivative as a function, but it can find the derivative at a specific point. Second calc dy dx, and then I just type in negative 1, enter, and it says the derivative is negative 48.000. Confirmed. Okay, let's do the second one. Let's do this one. So if this is u and this is v, we can use product rule. So u equals x, v equals, and I'm going to rewrite it as 1 minus 2x to the 1/2 because it's easier to take the derivative of. U dash is 1, v dash is equal to 1/2. Oh my god. 1 minus 2x to the negative 1/2, chain rule, negative 2. Let's rewrite v dash as negative 1 because negative 2 times 1/2 is negative 1. 1 minus 2x to the negative 1/2. Okay, and now I can multiply these two together and multiply these two together. So 1 times 1 minus 2x to the 1/2 plus x times, oops, it's a negative there, 1 minus 2x to the negative 1/2. Okay, I don't think we can simplify that too much. Now we're going to check, oh, and then we substitute in x equals negative 4. So we're going to put negative 4 there, we get negative 4 there, we put negative 4 there. So 1 minus 2 times negative 4, that would be 1 plus 8, which would be 9. Square root of 9 is 3. Negative 4 times, and we put negative 4 in there, we get 1 plus 8, 9. 9 to the negative 1/2 power. So that would give us 3 plus 4, and then 9 to the 1/2 power is 3. 3 to the negative 1 is 3 in the bottom. So 3 plus 4/3 is equal to 9 13/3. Okay, which is equal to 4.3 repeating. Let's confirm that by using the calculator. So I'm going to type this into the calculator, the original function, not the derivative. So I just put 1 minus 2x to the 0.5 power because that's a little bit easier than going back and typing the square root. If I wanted to put the square root, I would do second this button here, and then I would get the radical sign, right? So I graph that. And then I'm going to do second calc dy dx and type in -4. And that's going to give me, hopefully, 4.33. So second calc dy dx, which is number 6, and then type in -4. And the answer is 4.33. Yay, it worked. Okay. You can also see that with this version of the calculator, it also gives you the y coordinate that goes along with x equals -4. Okay? All right, that's it for this page.